Okay, this is what we did prior. So all of this was completed. This is all in standard form. The notes for today are going to be in factored form. So make sure that you get that worksheet. If not, you can go ahead and try to copy that down if you like. But I did give a worksheet during class to make it a little bit easier. So factored form, key items to graph. When you are graphing stuff in factor form, make sure you're graphing the x-intercepts, the line of symmetry, and the vertex. Okay. Let's talk about the steps. First, you're going to write your equation in factor form, which is y equal to a times x minus r1 times x minus r2. I know this looks weird, but just understand that these are your roots, which are the same thing as your zeros or your x-intercepts. And to get it in this form, you're just literally going to factor it, okay? Start off with your regular terms and then factor the heck out of it, and you should be fine. You're going to find your zeros by solving 0 equal to a times x minus r1 times x minus r2. No, that sounds complicated, but you know how to do that. When we go through it, it'll sound familiar to you. Once you have your x-intercepts, then you're going to go ahead and find the middle of your x-intercepts, and that's going to be the x value of your h comma k. Remember that your h is the same thing as the first part of your vertex. Then whatever number you get, you're going to plug that x back into your function, and then that's going to give you the y value of your h comma k, which again is your vertex. And it'll make sense as we go along. Okay, so it says a quadratic equation that is completely factored is considered to be in factor form. To graph this, use the factors to find the x-intercepts, then use the intercepts to find the line of symmetry and the vertex. So let's just go ahead and jump into it. I want you to notice right away that this first one is in factored form already because it's completely factored, right? You have a parentheses and a parentheses. In this case, your a value, the number in front is 1, and that tells us a lot. Number one, that tells me that it's concave up because it's positive. And number two, it tells me that there is no stretching or compressing going on. It's going to be a regular looking graph. All right, so let's go look at the steps. Step one, write your equation in factored form. It's already in factored form. That is done. Step number two, we're going to find our zeros by solving and setting it equal to 0. So let me go ahead and write this. Instead of writing that equation, I'm going to write 0 is equal to x minus 2 times x plus 4. What they're asking is what value of x is going to make this entire equation 0? Well, we've done that before. It's going to be when x equals 2. That's when you get the first thing to be equal 0, because in that case, it'd be 2 minus 2, which becomes 0. Then when you multiply 0 by a number, that still becomes 0, and it works out, okay? What about for the next one? Well, the next one, what makes that part equal to 0? Well, it's negative 4. Because if you plug in negative 4 right there, negative 4 plus 4 is 0. And then when you multiply anything by 0, the answer is 0. So I want you to understand what we just found. We just found the zeros of the function. Zeros is the same thing as your x-intercepts. And your x-intercepts are the same thing as your roots. So these are all synonyms of one another. That's why over here they have it in R's. R standing for like your first root and your second root, okay? So you found your zeros, you found your x-intercepts, you found your roots. Remember that there are also x-intercepts. So on your x-axis, this is your x-axis, you're going to know that it's going to cross that x-axis at 2 and at negative 4. So at 2 comma 0 and at negative 4 comma 0 is where your x-intercepts are at. Okay, so step one is done because it was already in factored form. Step two is done because I found my zeros. Step three, I need to find the middle value of my x-intercepts. So because I know that this is going to look like a U, it's either going to look like a U that looks like this, or it's going to look like a U that looks like this, right? But I know that this is 1, so it's concave up. So that means my vertex, it needs to look like this, which means my vertex is somewhere down there. So I better get a negative value for this vertex, okay? Somewhere down there on the bottom. All right. Hey, I said, because it looks like this, your line of symmetry also needs to be somewhere in the middle of those two lines. Now, visually, I can kind of see, oh, it looks like it's going to be at negative 1. But if you can't see that visually, you can use your fingers to work your way to the middle. Or what I would rather do is I would just take the average of these two numbers. The average of -4 and 2 will give me the middle number. So in order for me to find the average, you just add the two numbers together. I'm going to add the 2 plus the -4 and divide by the number of numbers, which in this case is going to be, there's only two numbers. You take the average, that's going to give me -2 divided by 2, which is -1. So the line of symmetry, the middle number, is going to be at x equals -1. X equal to -1 is my line of symmetry. All right, guys, I'm basically halfway there as far as the vertex is concerned, because I know the vertex is going to occur somewhere where x is -1. I'm halfway to my vertex. What I don't know is my y value. And just like in the previous section, the way you find your y value if you have your x is you just plug it into your equation. So I'm going to write right here, you are going to plug it in. All right, we're going to plug in our -1. So what I get is y equal to -1 minus 2, parentheses, -1 plus 4. All I did was I plugged in my -1 into my equation. When I do that, I get y equals -3 times +3, which means y equals -9. I just found the second part to my vertex. That means I should know where my vertex is at now. My vertex is at -1 comma -9. I'm going to go ahead and plot that. That goes right here. And that makes sense because remember, I told you earlier, because it's concave up, that my vertex was going to be somewhere down here. And sure enough, it's right there. Hey, you don't need to be super technical with your dots for this problem. Just know that we're sketching, so my graph should look something like that. Okay, it's a rough sketch. Okay, so that takes care of the first one. Let's go ahead and sketch the second one. We're going to go through the same process. First things first, I noticed that my graph, my equation looks like this. It's already in factored form because it's completely factored. So a couple of things to note. Number one, this is concave down, and it's vertically stretched by a factor of 2. So I'm imagining a graph that not only is concave down like this, but is probably going to look a little bit on the skinnier side because of that stretch, right? That 2 is going to stretch that out. So let's go ahead and start solving this right away. I'm going to do this by solving my x-intercept. So I want 0 is equal to -2 times x minus 5 times x minus 3. My zeros must occur at x equals 5, or it must occur at x equals 3. Because again, if I plug in 3 here, 3 minus 3 is 0. And then when I multiply 0 times all of this, I get the answer of 0, which is what I want. So what did I just find? I just found my zeros, which are the same thing as my x-intercepts, which are the same thing as my roots. So I have my zeros, I have my x-intercepts, I have my roots. My x-intercepts are at 5 and 3, so here's 5. Remember, this is my x-axis. Here's 3. I got two x-intercepts. The first one is at 5, 0, and the other x-intercept is at 3, 0. Now that I have my x-intercepts, I can find the line of symmetry. The line of symmetry needs to be right smack in the middle of those two. And it looks like this time my line of symmetry is passing at x equals 4. Hey, if it's easy to tell, then just go ahead and write x equals 4. I'll be able to understand. If it's not easy to tell, if you're not sure what's in the middle of 5 and 3, you can always average them out. Add them up, divide by 2. That's 8 divided by 2, which, oh, look at that, it's equal to 4. Hey, you found the line of symmetry. It's x equals 4. That's also the first part of your vertex. In order for you to get the second part, you're just going to take your number and plug it back into your equation. We are going to plug in that x to get the second part of the vertex. So I'm going to write y is equal to -2 times 4 minus 5 times 4 minus 3. All I did was I substituted my x values. That means y is equal to -2 times -1 times +1. And if you multiply those numbers together, you get y is equal to 2. You just found the second part of your vertex, which means your vertex must be at the point 4, 2. 4 comma 2, I put a dot. I'm going to go ahead and sketch what I think this graph is going to look like. And that makes sense because I do have something that's concave down, and I ended up with something that's concave down. So I'm pretty sure I probably did this right. Okay. All right. So that takes care of the simple ones. Let's do two more that are a little bit more tougher. I want to graph this in factored form, and unfortunately, right away, I noticed that it's not in factored form. So how do we put it in factor form? In order to put it in factor form, you need to factor it. Okay. What's always, always, always the first step in factoring? It's to factor out the GCF. Remember that if it starts with a negative, then you need to factor that out. So I'm going to factor out the GCF, which in this case is going to be -1. Y is equal to -1. When I factor that out, to get this back, I need a positive x squared, a -6x, and a positive 8. Okay. Is that completely factored? Nope. I can factor this part in here. The way I'm going to factor that is I'm going to use X method. On the top, I need an 8. On the bottom, I need a -6. What two numbers multiply together to multiply to positive 8 and add up to -6? That would be a -4 and a -2, because -4 times -2 is positive 8, and -4 plus -2 is -6. Hey, I should check. Do I need to change these into fractions? No, because there is no number in front of that x squared, so I don't need to do that. Okay, so when I factor this, and this is going to be y equals negative parentheses parentheses, we said that the answer is x minus 4 and x minus 2. X minus 4, x minus 2. Now that it's in factored form, now I can go ahead and start with the process. So step number 1 is done. I wrote the equation in factored form, check. Now I need to set it equal to 0 and find my roots. So let's set these equal to 0. In order for me to get a 0 here, I need x to be 4. In order for me to get a 0 here, I need x to be 2. These are my roots. These are my zeros. These are my x-intercepts. So on the x-axis, I get to plot these at 4 and at 2. Those are my two x-intercepts. The first x-intercept is at 4, 0. The other x-intercept is at 2, 0. Now, because I have the two dots, I can go ahead and find the line of symmetry, which needs to be right smack in the middle of those two. And it looks like this equation for the line of symmetry is the x equals 3 line. If you didn't know that, you can always average them out. 4 plus 2 divided by 2 is 6 divided by 2, which is 3. You're going to get the exact same answer. Hey, so far you know the first part of your vertex. You just need to get the second part of the vertex. To get the second part of the vertex, you plug it in. So I'm going to take that 3, plug it into your equation. Now, you can plug it in here, or you can plug it in here. Both ways are going to work. Me personally, I think these ones are easier. So I'm going to plug it in right here, and let's see what we get. I get y is equal to negative parentheses 3 minus 4, parentheses 3 minus 2. All I did was I took my x value and I substituted it here and here. All right, let's go ahead and calculate this. This becomes y is equal to negative parentheses -1, parentheses 1. Negative times a negative is a positive, and then this just becomes y is equal to 1. That should finish out my vertex. I know my vertex is at the point 3, 1. 3, 1, put a dot, sketch the rest of my graph, and I think it's going to look something like that. All right, we are down to the last one, guys. On the last one, same thing. We need to put it in factored form. Obviously, to put it in factored form, you need to factor it. So first step in factoring, always, 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 is factor out the GCF. My GCF in this case seems to be a -2, so let me factor that out. It's going to be y is equal to -2 parentheses. How do I get this back? I get this back with an x squared, a plus 4x, and a plus 3. Okay, that's still not factored because I can factor the stuff inside the parentheses. I'm going to do that by using my x. On the top, I put a 3. On the bottom, I put a 1. What two numbers multiply to 3 and add up to 4? Excuse me. Multiply to 3 and add up to 4. That would be 1 and 3. I check, do I need to make these into fractions? No, because there is no number in front of the x squared. So this is going to be what it factors to. y is equal to negative 2 parentheses, parentheses. And you told me that answer was x plus 1 and x plus 3. X plus 1, x plus 3. All right, now that it's in factored form, I can find my zeros. The first way this is going to become 0 is with x is equal to negative 1. The second way this is going to become 0 is if x is equal to negative 3. Those are my zeros. Those are my roots. Those are my x-intercepts. So let me go ahead and plot those at negative 1 and negative 3 on my x-axis. Now that I have that, I can draw the line of symmetry. Line of symmetry right here is at x equals negative 2. If you didn't know that, you can always average them out. That gives me negative 4 divided by 2, which is negative 2. You are halfway to knowing your vertex. How do I get the other half of the vertex? Well, you need to take your x and you need to plug it in. I'm going to plug it in into this equation right here. My x is going to get replaced with that negative 2. So let me write down that equation. That's going to be y equals negative 2 times parentheses my x, which is a negative 2 plus 1. And then negative 2 plus 3. That's me substituting my x into that equation. Now I just got to solve. So this is y is equal to negative 2 times parentheses negative 1 times positive 1. Negative negative turns into a positive, so you get y is equal to positive 2 when you multiply everything together. That means my vertex must be at negative 2 comma 2. Negative 2 comma 2, put a dot, and I get to sketch the rest of my graph. All right, that's all the notes for today. If you have any questions, as always, you are free to ask.